Hello and welcome to Train Signal. You're watching reporting, troubleshooting, and performance monitoring of Linux. This is part of Fast Track CBT Video, Linux Networking and Administration. In this video, we'll be learning how to monitor system performance, how to document Linux, troubleshoot Linux with system log files, and accessing documentation in Linux. So let's start off with monitoring system performance. Now Linux Plus Objective 5.1 says you should be able to establish and monitor system performance baseline. For example, using the commands top, sar, vmstat, and pstree. Now besides knowing how to get periodic performance information, you should develop a documented performance baseline. A performance baseline is something that allows you to compare what's happening now with what was happening in the past. So, for example, when you first bring up a new server and you put users on that server, you take a performance baseline and you analyze it, and if there are problems, you fix those problems, but you need somewhere to start, and you record that performance baseline and keep it on file. And then say a week from now or a month from now or a year from now, if you have more performance problems, you can go back and compare the current performance statistics to the previous performance statistics, and you can see how things have changed over time. Because right now, if you were to run the free command and see that there's 512 KB of memory free, well, is that good? Is that bad? Who knows? You're only going to know if you've done some performance baseline in the past. So some common performance commands are listed here, and they are uptime, free, df, hdparam, sar, top, vmstat, pstree, and the Fedora GUI system monitor, which is actually run from the command line, and it's run as GNOME system monitor. You can also go up to the menuing system and run it there from the graphical interface. So there's nothing better than going and seeing these commands on the real system. No need to sit around here and talk about them. Let's go run them and see what they do. Alright, so I'm over here on our Linux server, and I'm going to bring up a command prompt. Alright, so first let's run the uptime command. The uptime shows us how long the system has been up. 7 days, 1 hour, 18 seconds. There are 2 users on, and this is the load average over time here. So that's the uptime command. How about the free command? Free shows us how much memory is free, what our total amount of RAM is, how much is used, and how much is free. And don't panic about how much is free, because Linux by default will use pretty much all the available memory and then push everything else out off onto swap. So having a very little memory free is pretty common in Linux. The next command is df. Df, I think of it as disk files, but what it does is it shows you the different file systems that are mounted and the virtual disk that they're mounted on, and then how much is total disk space is in that file system, how much is used, and how much is available. So that's what df does. It tells you what file systems are full and what file systems have free space. The next command is hdparam, and it's used to test the performance of the disk as well as make performance changes. Now you can run it with the -t switch, and you give it the name of your disk drive, and what it does is a performance test on that disk drive, timing buffer disk reads, and it gives you some statistics. Now for some reason there's an error here. I haven't investigated the error, but it did give us some performance statistics here. It said it transferred 16 megabytes in 3.1 seconds, which is a transfer rate of 5.14 megabytes per second. So you can use hdparam to also configure disk settings and do performance tuning on your disk. Now we talked about SAR, the System Activity Reporter. SAR has to be installed. SAR isn't installed on this Linux system by default, so I'm not going to run SAR. but SAR is a package that can be used to monitor the system, check things like RAM, disk, and CPU, as well as other things like network, and you can set it up to run in the background and record things. So that's what SAR is. Let's run top. Top shows you, as well as the uptime and the number of processes, it shows you what the CPU is doing, the amount of memory, the amount of swap that's free and used, and then the different processes. And it shows you in order of who's taking the most CPU, who's taking the most memory, who's the owner of that process, and the PID number. So this is what top is, and it's a great program to sort of analyze everything all at the same time. The next one is VMstat. VMstat works by you giving it two positional parameters out here. The first one is the number of seconds to take a capture for, and then the last one is the number of repetitions you're going to take captures. So it took a capture for 1 second, and it did 5 repetitions. So for 5 seconds it took captures, and then down here it showed me those statistics here. 1, 2, 3, 4, 5. 5 different captures of 1 second each. And it shows me the, you kind of have to read the man page really to understand this, but here's the processor statistics, the number of processes that are runnable, and the number of processes that are bound. The memory statistics here, how much is swapped, how much is free, buffered, cached, swap in, swap out, I/O in, I/O out, system, CPU, the number or percent of CPU that's being run by user processes, system processes, idle processes, and waiting processes. So that's what VMstat does. It just keeps on going, giving you statistics based on the number of repetitions and the number of seconds you ask it to take a capture for. Alright, the next one is pstree. This is a process tree command. So it's going to show you all the processes on the system, who owns them, and who the parent PID and the child PID are, in sort of a tree, like a graphical format. So let's see it. It went by really fast there, but if I scroll up, okay, you can see here, here's a NIT, and a NIT started all these different processes here. This one, GNOME Terminal, started bash and pstree. That's our pstree we just ran. It also started GNOME PTY Helper and GNOME Terminal. Let's see, kthread started all these. Xorg, started this one down here. So you can kind of see how it's a tree with the lines and the branches, and you can see what process started other processes. So it's a pretty cool performance tool. So if you know that there's some process like SSH agent that's taking everything over, you can see, oh, GNOME session is the parent of that, and GDM binary is the parent of that, and so on and so forth. Alright, so the next command is the GNOME system monitor. I can either type GNOME system monitor here at the command prompt, or I can go up here to system, administration, and down here to system monitor. So I'm going to do that. I'm going to click there. And this shows me all the different processes on the system, their status, how much RAM they're taking, time in the CPU, their niceness value, security context, who they're running as. You can scroll over here and see the arguments for the application. You can click on one and you can end a process. You can see the load average here for the last 1, 5, and 15 minutes. You can sort processes by name, by CPU type, however you want to do it. On this tab here are resources. So here's a graphical view of the CPU utilization, graphical view of memory and swap, and a graphical view of network history, received bytes in and out. You can go to devices. You can see your hard drives here. So here's the primary disk here. It has 7.1 gig, 4.4 gig free, 4.1 gig available, 2.7 gig used. And you can see a little graphical chart over here that shows you it's 39% full. If I go up to view here, I can see, I can set different things, set preferences, but I think you get the idea. This is a very handy graphical tool to allow you to check out the performance of your system when it comes to CPU, RAM, hard drive, network, and running processes. So I'm going to quit out of this, and we'll close this out. So that's the end of the different performance commands I wanted to show you. Let's go back to our slides. Alright, so we checked out these commands on the Big Sky Fishing Supply Linux server. Now let's move on to documenting. Concerning documenting Linux, Linux Plus Objective 5.2 says you should create a written procedure for the installation, configuration, security, and management of a Linux system. Objective 5.3 says you should document installed configurations, for example, installed packages, package options, TCP/IP settings, assignment list, changes, configuration, and maintenance. Now to do this, you're going to have to know your Linux distribution and versions. If your server was stolen tonight, or you had a fire and the server caught on fire, and you had to rebuild it and reinstall it, you'd have to know what version of Linux to install. What distribution? Is it Fedora? Is it SUSE? What is it? And then you'd have to know what hardware you were using. Was it a single processor, dual processor? How many disks did it have? What was the disk partition layout? Well, you could use fdisk-L to record that. Put the name of the hard disk here. You could redirect it to a file, and then you could copy it to a CD drive or a flash drive, or you could print it out. Now you'd have to do this for every disk on the system, and you could also print out the etc fstab file for file system table. You'd want to know what software you have installed and what choices you made when you installed the software packages. Now you could record this with rpm-q for query, -a for all, and redirect that to the installed packages.txt. There's hundreds of installed packages on a Linux system. Even if all you do is just install the defaults, there's lots and lots of packages and different versions installed. You'd also want to know what options you chose at the time of installation. Now to record these, every administrator should maintain a written administrator's log. This is real paper in a book or a binder, whatever it is, next to the server console or wherever it is you do most of your configurations. Now in this log you'd have the initial configuration, the package information, the configuration file edit history, so any changes you make to configuration files, any file system changes you make, any kernel compiling you do, any hardware changes, or even corrections to earlier entries. So whenever you install a new patch or a new application, you write it down. That way when it comes to recreating the system, or you have a question about things aren't as stable, things aren't working as well as they used to, or you need to remove something and reinstall it, you know where to go to look for information on that. You have this logbook. Now make sure you don't record any kind of passwords in the logbook, because someone could walk up, pick up the logbook, see the passwords, and go have administrative access or whatever that password allows. You should also make sure you perform regular backups of all computers and servers. That way, if you had a regular backup tape that you could restore that was up to date, you might be able to get that server back up pretty quickly without reinstalling Fedora Linux. Now you should take the time to back up important configurations such as those in the etc directory. You can do this with the tar command, and you could even send it to a floppy using this command. First you'd have to mount the floppy, then you would use tar with a compressed switch, that's the C, C is create, Z is compressed, F is for file name, and V is for verbose. So you're sending it to this file name here, this etc.tgz, and you're backing up the etc directory. That's all the different configuration files on the system. So you want to keep that file in a secure place, of course, because it has the etc password and etc shadow files in it. But it would be great to be able to have that file to restore, if not a backup of the entire system. Now every administrator should develop documentation of policies and procedures. These policies and procedures might be for the administrative staff, such as yourself, or for the users. Some of the examples of things you would want to put in those policies and procedures are Who has access to the root account and why? What applications are accessible and to who? What shared directories are created and to who? What data should go in the public folders? What's the emergency procedure for the data center or for a server crash? Who do you call? Who's going to stay up all night and restore it? What is our service level agreement to the users? Is it acceptable to them if the server is down all day? What software is installed on the servers? What's the procedure to add a new user or set up a new printer? Does the manager have to request it, or you just call and they do it? Do you have a person dedicated to creating new users, or how does that work? You need to develop documentation, and I'm sure it'll take time, but it's an important task. So now let's move on to troubleshooting Linux. Concerning troubleshooting with system log files, Linux Plus Objective 5.4 says you should be able to troubleshoot errors using system logs. For example, they say head, tail, and grep. Those are 3 different commands you could use to look at those log files. Then 5.4 says you should be able to troubleshoot application errors using application logs. For example, tail, head, and grep. So this is system logs here, 5.4, and this is application logs down here, 5.5. Now these common commands that would be used to examine log files, besides the 3 they mentioned up there, which were tail, head, and grep, there's also dmessage, which shows you the kernel logging buffer, the more command, the less command, and the cat command. These are all good commands to look at different log files. Now you can look in the var log directory, and that's where most of the important files are. For example, var log samba is in that same directory. Samba is where the Windows file system or Windows file sharing server places its log file. And that would be an example of an application log. There's also system logs that are contained in var log. Now one thing you could do is modify the syslogd server with the etc syslog.conf file to determine what logging information will be stored in what log files and at what level, what severity, how much detail. Another thing you can do is use the log rotate command. This is configured with etc logrotate.conf, and what it does is it takes long log files that grow and it sort of archives them. It might keep 3 copies of this one file over time and migrate out anything older than however many log entries it can fit in those last 3 copies. So it sort of gets rid of the old data. It's like a constant purging program. So why don't we go take a look at some of these different Linux troubleshooting and system log file analysis tools over on the Big Sky Fishing Supply server. Alright, so we're over here on the Big Sky Fishing Supply Linux server. I'm going to open up a terminal window and I'm going to cd into var log. I'll do an ls here, and there's a number of log files in here, and we're going to be working with the messages log file, one of the most common Linux log files. And let's practice these different commands on that log file. So I'm going to clear the screen, and let's say I type in tail messages. Okay, what that did is it gave me by default the last 10 messages, last 10 lines in the messages file. I could also do tail -2 messages. This would give me the last 2 lines of the file. There you go, last 2 lines. Now I could use head -2 messages to give me the first 2 lines of the file. Let's say I was looking for something particular. I could grep, or no, let's combine 2 commands. Let's use cat. That's another one we're talking about. Cat, which actually stands for concatenate, by the way. So stick 2 things together, but it doesn't have to be used to do that. So I'm going to cat messages, and I'm going to pipe it to grep. And then with grep, I'm going to type in something that I'm looking for in the file. Let's say, I'm going to put it in quotes. Wrote 41 leases. Alright, so that happened 1, 2, 3, 4, 5, 6 times. Hey, what if I pipe this to word count? I can see word count tells me there were 6 lines right there. It happened 6 times. That's WC, word count. So let's see, another program here we can use to analyze this is More. I can more the messages file, and it shows me page by page. So if I press space here, it just keeps scrolling through the messages file. I can press Q to quit, and if you do the man page on More, you'll find out it has a lot of features. The other command is Less. I can do less on messages, and it looks like the same thing initially, but I can do commands here too, and you can do a lot of different things with less. I'm not going to go into all of it, but you can. So there are system log files we talked about, like messages, and then there's application log files. So like if I cd here into Samba and do an ls-l, you see there's an smbd.log. That's an application log. That's the Samba SMB log file. So you can see all the different log files and different log file analysis tools that are available in Linux. Let's go back to our slides. Alright, and we can move on to our next slide where we talk about accessing documentation in Linux. Linux Plus Objective 5.6 says you should be able to access system documentation and help files. They say, for example, man, info, readme, and web. Well, man and info are two different programs that you use to look at text-based command help windows in Linux. Readme is a file that you would find on the CD or on the installation folder, in the installation folder of some application you're installing. And then web would be web pages you can go out and find to read more about Linux and learn more about Linux. So first off, let's talk about man pages. Man pages are excellent resources, and they're broken up into sections. These sections are 1 for executable programs and shell commands, 2 for system calls, 3 for library calls, 4 for device files, 5 for file formats, 6 for games, 7 for miscellaneous, 8 for system admin commands, which are the root programs, and 9 for kernel routines. So what you can do is type like man space 8 space shutdown. So that would just show you the man page for kernel routines and then shutdown. If you just type man space shutdown, you might get a lot of different web pages that maybe don't have to do with shutdown or something like that. This way you can more quickly get to the section of man pages that you're looking for. Now at the bottom of most man pages there are examples. These examples are very handy. They'll show you how to use the command and some common tasks and the commands you use to perform them. So if you're not familiar with them, a lot of times you can just copy off of a man page an example and use it. Man output is presented using the less program. So if you learn less and you learn how to search and do things like that, cut and paste in less, you can do it in man. Or you can do it when you use a man page or view a man page. You can do those less commands with man. Now the what is program searches the man summary information only, for keywords that you specify. The apropos command searches the man page name and description information for keywords that you specify. So when you do an apropos, you'll get lots of information, and we'll do it in here in just a minute. The next one is info. Info pages are very similar to man pages, but they're presented with a nicer, more featured-rich interface. You can actually select hyperlinks in info pages with cursor keys. Now make sure you read any documentation that comes with applications you choose to install. These applications almost always come with a README file and an install text file. These help you understand what the requirements for the application are, what you have to do to get it installed, and maybe some particularities that apply to certain servers or certain hardware or certain distributions of Linux. Now an excellent resource for Linux help is the Linux Documentation Project. You'll find it at www.dldp.org. They offer how-tos, frequently asked questions, and guides. So let's take a look at the Linux Documentation Project. Here it is. Here's the how-tos. Here's the guides. These are longer, in-depth books. Here's the frequently asked questions. And here's the online man pages for Linux. There's also things like the Linux Gazette, and Linux Focus magazines. You can get an RSS feed from here, and you can get all sorts of great information about Linux and Linux documentation. So let's close this out. And now let's go take a look at these tools on the Big Sky Fishing Supply Server. Let's go try them out on our real Linux server. Alright, so if I type man space 8 space shutdown, 8 is the section of web pages for administrative tools and kernel routines. If I press enter there, it shows me that shutdown is the bring down the system command. That's what it does. It brings down the system, and it gives you all the different options. You can see the little 8 up here shows you what section you're in. Down here it says see also FSCK, which is in section 8, init, halt, power off, and reboot, all in the same section, section 8. So I'm going to hit Q to quit there. Now let's type what is bash. So the what is command searches the headers and the summary information of man pages for the keyword that you specify. So I didn't get many hits because it's just looking in the header information or the summary for these different man pages. On the other hand, if I type apropos, I get lots and lots of entries here because apropos searches through entire man pages for whatever word it is that you specify. In this case, I typed in bash. Alright, so the final tool I want to show you here in getting help information is the info command. Info is a lot like man, but it has a better search interface. So if I type info space bash, so inside the bash interface, it's a lot like man, but I can scroll up and down here and I have a lot more features. If I find a sort of a hyperlink type thing, I can click on that and it might take me to some other man page. You can type question mark to get help on here, and there's a lot of different things you can do with it. So info is a lot like man, but has some more features. So with that, we can go back to our slides. And we just finished looking at how these different documentation tools in Linux can be accessed, so you can pull up a lot of different information on how to configure Linux. Linux, of course, is very complex, and the more documentation and examples you can find, the better. So this is the end of video number 21, where we learned about reporting, troubleshooting, and monitoring the performance of Linux. We talked about how to monitor system performance with commands like uptime, free, df, top, vmstat, and the GNOME system monitor. We talked about documenting Linux and the importance of having a system administrator's manual. We learned how to troubleshoot with system log files by using tools like tail, head, grep, more, less, and cat. Then we learned about accessing documentation in Linux using man pages, the what is tool, the apropos tool, and the info tool. So we learned a lot about reporting, troubleshooting, and performance monitoring in Linux. This is the end of video number 21. Thank you very much.